Hey everyone, welcome back to the YouTube channel of Developers and Coders Club. So today we are going to discuss the problem C of present context of Codeforces round 887. In this question, we will be given two integers n and k. So initially we have a sequence of 1, 2, 3, 4 until 10 to the power 1000. And in this sequence, we will remove a1th element, add to the smallest number, a and the smallest number from us. And our task is to find out the smallest element in us after k days. So we will given n and k, and after that we will given a unsized array. So if you see for this one, 5 3 1 3 5 6 7. So let me write this sequence which we have initially. I think that will be sufficient. So in this sequence, what is on the first day, we will remove first smallest number, third smallest number, fifth smallest number, sixth smallest number, and seventh smallest number. So first smallest number, that is this. Third smallest number, that is this. Note that like on the same day, we are not changing our sequence. On the same sequence, we are applying. Like on the first, this is the first smallest number, and for these three, note this is like 2 4 5. Note this is the third smallest number. This will be the third smallest number. Why? Because 1 2 and 3, we have to consider this one for the same day. So 1 3 5 6 and 7. This is all about on the first day. Then if we we will given k value of k is 3. So on the second day, this will be the first, this is second, this is third, this is fourth, this is fifth, this is sixth, and this is seventh. And on the third day, this is first, this is second, this is third, and this will be fourth, and this will be fifth, sixth, and seventh. So this is the sequence which we are getting after 3 days. So which is the smallest number which we are getting after this? That is 9. So answer for this one is 9. Cool. Now let's see from an example let me write first the sequence. This is the initially we have the set of numbers. Then just consider that we have the array A is 1, 3, and 5. Okay, that's enough. Now in this array, if we perform operations like for k equal to 2, so for this, on the first day, 1, 3, 5, this will be removed. On the second day, this is first, this is second, this is third, this is fourth, this is fifth. So these are the elements which will be removed after 2 days. And 4 is the number which is the smallest number which will be left after 2 days. So for this one, we will output 4. So what is the idea behind the solution that I will put a binary search? And in this binary search for every mid, I will check that is it possible that from 1 to this mid, okay, I will check that how many operation I need for remove all elements from 1 to mid. Listen again that what I am saying, that I want to check that how many operation I need, how many days I need to consider that all elements from 1 to mid will be removed. Like just consider that is lambda. So after lambda days, all elements from 1 to mid will be removed. So if this is lambda is more than k, there can be two conditions. Either this lambda is more than k or this lambda is less than or equal to k. So if this lambda is more than k, so can I say that in k days there will be some element from 1 to mid that will be left out? Because what is lambda? That is the minimum number of days, that is the minimum number of days which will be required for removing all elements from 1 to mid. So if lambda is more than k, so from that I can say that if we consider only k days, then there will be some element which will be left out. And if lambda is less than or equal to k, in that case I can say that after k days, there will not be any element from 1 to mid which will be left out. Okay. So from here we can consider our direction of the binary search, that if lambda is less than k, lambda is more than k, then I can say that or one of the answer of the problem can be mid. Why mid? Because you are saying that okay, from one to mid, there will be some element. From one to mid, there will be some element which is left out. So either that can be mid or that can be from this range. So I can make n equal to mid, and I can update our range of binary search from A to mid minus 1. And in this case, I am saying that okay, after k days there cannot be an element from 1 to mid which will be left out. So in that case, I will say that update our binary search from S to mid plus 1. So now thing is that how we are going to check, that how we are going to calculate this lambda. We are going to simply implement a binary search, and like us will be 0 and it can take equal to 112. That can be the maximum value of the number which can be left out. So we will print we will make binary search for this one, calculate value of mid, and check. There is a function check which is checking for this condition. Is lambda is more than k, then the check function is true in this case, and in this case that is false. So if that is, then we are going to do this one, and in this case we are going to do this one. Now our whole target is to find out this check function, that how we are going to calculate that what is the this is true or false. So for that, now consider the same sequence for this one, and I am saying that 135, and we have sequence till 10 power 1000, and just consider that we are checking mid, and value of this mid for this example is let's take that as 11 or take that 12. So what I am going to check, that is the number of days which we have to consider, that all elements for those days, all elements from 1 to 12 will be left, will be removed. So just consider that is lambda. That lambda is the number of operation, number of days which we have to consider, that all elements from 1 to 12 which will be removed. And that now we how to calculate this lambda. So for that, what I am doing, that okay, let me increase the number in this, that our sequence is 1, 3, 5, 15, 17. This is the given array A. Now what I am saying, that if value of mid is 12, if value of mid is 12, so just tell me that these operation 15, 17, as this will contribute any on any day in this range from 1 to 12. The operation 15, 17, they will not contribute on any day, because on the first day they will remove elements from this side. And what we are going to consider, only elements from 1 to 12. Okay, so what I am doing, that I am iterating a loop from this side, and if the number of current element is more than our mid, if that is more than our mid, then we are going to do nothing, we are just continue on that step. And on these steps, like we are getting 5. So what I am going to calculate, that how many days we can consider, that Like just consider an x. On this x, I'm going to say that for x days, this element will contribute in this range. Listen again that what I'm saying. That for x days, this element will contribute in this range 1 to 12. After x days, like x plus 1 days, this element will remove some element from this side. But for x days, that will remove elements from 1 to 12. So, like make it more visualized. So for that, I'm going to consider for this 5. So just tell me that from 1 to 12, uh, how many elements are there? 1, 3, 5. We are going not going to consider this one because they are contributing on this side. So from 1, 3, 5, can I say that initially there were elements 1, 2, 3 till 12. So there were total 12 elements. But after first day, there were left only 9 elements because 1, 3, 5. These three numbers have removed 3 elements. Am I right? That among these 12 elements, these three have removed 3 elements. So after that, we have left 9 operations, 9 elements. So on second day, can I perform this? I think yes. Why? Because 5 is less than 9. 5 is less than equal to 9. So from that I can say that the fifth smallest element I will get in this range 1 to 12 because the number which the elements which are left out is 9, which is more than 5. So yeah, I can say that on the second day also I can use this element for uh, removing the element from 1 to 12. Okay, so after second day, the number of elements which will be left out will be 9 minus 3 because three numbers are removing. So 9 minus 3, that is 6. On the third day, again I can remove. Again this 5 can contribute because what we are saying that we want to remove fifth smallest element, and we can get our fifth smallest element in these six numbers. So after these six, three elements will be removed, and this will be converted into 3. On the fourth day, I cannot perform operation. Why? I cannot use this 5. Why? Because the number of elements which are left out in range from 1 to 12 is only 3. So if I am saying that we want to remove the fifth smallest element, that will be removed after this 12. Because only 3 elements are left out here. So there will be some element, there will be some element. So this will be removed. So for this 5, I just want to calculate that number of x, that is the number of days for which this 5 will contribute. This x should be 3 because we have seen there. So how to find this one? So just consider that value of our range, that is mid, that is 12, and we want to remove like that is x. So can I say that I will remove uh, I plus 1 elements x times from this mid. Again listen that I am saying that for x days that 5 will contribute. Okay, so for those x days, can I say that for that mid range, like for that 12 elements, x into I plus 1 elements will be removed because for this is 0, this is 1, this is 2, so I plus 1, that is 3. So for every day we are removing 3 elements. Okay, so for x days we will remove x into I plus 1. What should be the value of this range? What should be the value of this range? Can I say that that should be like minus x into I plus 1, that was 3. This should be more than or equal to 5. Is it right? Why? Because like if we consider such a x for that this value is less than 5, in that case we cannot remove the fifth smallest number. Are you getting that? I am saying that only for x dash I will get such count of elements, from that I can remove fifth smallest number. So for that, the number count of elements should be more than or equal to 5, because from that only I can remove that fifth smallest number. So from this I can say that mid minus x into I plus 1 array of 5. For this x number of days, I can remove basically for x plus 1 days. Why this one? Because after 1 day also I can remove, because are you getting that the count of element is still more than array of 5. The count of element is still more than array of 5. So for one extra day, I can use that. Let me write again that what I am saying, that mid minus x into I plus 1, that should be more than equal to array of 5. So the x is the maximum number of days. The x is the maximum number of days on which we will get the count of element more than or equal to array of I. This is the last number of days. After this day, we will get the number of count of element less than array of I. So I can say that okay, for x days we can use that operation, but for one extra day I also can use that. Why? Because for x days we are getting the count of element more than array of 5. So for one extra day we will use that. So now we can calculate the value of x simply by using this formula. So that will be mid minus array of I upon I plus 1. This will be the value of x. And as I said, one extra. So what I'm saying, that I want to calculate the total number of operations for which the all numbers from 1 to 12 will be removed. So I'm saying that for x number of operation, for x plus 1 number of operation, this 5 was contributing. So for x plus 1 numbers of operation, that 5 was contributing. So I will add total number of operation plus equal to this x plus 1. Okay, like that is saying that 5 will contribute for this x plus 1 operation. After that, where is that? Yeah, 135 we have considered for this 5. After that we get that we are left in with only 3 elements, because we have performed for x plus 1 days, which means we have performed for 3 days, and till 3 days we have left out only 3 elements. Now for 3 elements we will consider 1 and 3. Like I will check that if 3 is the current element, then on the fourth day I will left out with only one number by removing 1 and 3, because I have removed 2 elements from this. And after this one, I cannot use this 3 because that is more than current I. So I will directly use 1, so that will make it 0. So basically what is the idea behind it, that I will hope that you will okay, you will understand from the solution. So here, so there is a edge case that if array of or array is not starting with 1, that is starting with 2, 3, 4, something other number. So from that we can say that on any day 1 will not be removed. On any day 1 will not be removed, because the deletion of the number will start from these days. So 1 will be always left out. So for that case, we will print 1. Otherwise, we are making a binary search from 1 to 112 and checking that is true. If that is, then we are updating our ans with mid and updating our e and s. Okay, then this is our function. Here what I am doing, that this is the total number of operations which we need to perform, total number of days which we need to consider. For that all elements from 1 to mid, all elements from 1 to mid will be removed. So for that, I'm iterating the loop from the back side. If that current mid is less than array of I, then we are not going to do anything because this array of I is contributing in the side after that mid. And otherwise, we are going to calculate the number of operation that will be x, that is mid minus array of I upon I plus 1, and one extra day. For that, I'm making x plus plus, then total plus x. This is contributing, this array of I contributing for x days, then mid minus x into I plus 1 y, because for x days we have removed x into I plus 1 elements. So because of that, we are updating our mid, and if anywhere we are getting our mid is less than 0, and there we will return false. Otherwise, we will check that is our total number of operations is more than k. If that is, then we can say that for k dash there will be some elements which will be left out. So we can say that is true. Otherwise, that is false. So you will get the code in the description. You can check out there. I hope you all got it. See you in the next problem. Till then, happy coding. Bye bye.